So what I'd ask is all the presenters, if they could turn their cameras back on. We've got about 10 minutes before we're normally due to finish at 12. We may go over slightly. And I'm going to select some of the questions from the Q&A window and pose it. Of course, we are short of time, but it's been a fantastic set of presentations. And I'm not going to apologize for the length of the presentations. I picked 4 questions. If you could do shortish responses. But I think the first one I wanted to pick on was from Louis about security. And his question was, which is intrinsically safer, the AI in the cloud or AI at the edge? And also broaden that to other specific things in terms of on-chip security devices that are beginning to make it more secure at the edge. Mark, do you want to start us off on AI cloud, AI edge, more secure?
I would say that if AI at the edge was isolated, if it wasn't connected to the cloud, then it would be AI at the edge. You know, there are fewer attack surfaces, but the reality is, I think most models will be connected as well. So I don't think there's a single answer to that. So I think as long as something's got a connection, then there is a vector of attack there. If you're storing your data on the cloud, I think that's opens up obviously much more access. So that suggests that the cloud is worse. So I think generally, if I was to be pushed to an answer, I'd say AI at the edge is more secure, but it's a little bit more nuanced than that.
Adrian, you covered quite a bit of moving AI from the cloud to the edge. Do you want to comment? And you're on mute at the moment.
Yeah, so. Sorry. Yeah, I think that there is a natural way that we are going to move more of the AI processes to the edge. But still, there is as I said in my presentation, there is a quite big research actions to be done on data privacy and how to guarantee that the sensitive data is not that does not leave the device. I think that there is still a lot of research action to be done.
And Nicholas, have you got any thoughts?
Yeah, I think it is going to become a really pressing question, especially now with the new cybersecurity standard coming out of the IEC, the 62443. So it's going to be a question much more asked. Generally, I would say whatever you keep local is sort of harder to steal in big numbers. So of course, there are still concerns. So even if I don't send up the, let's say, smart speaker, even if I don't send up the voice, I still send up some sort of signal. So it's not enough to do security at the edge device, but you have to think it all the way through. But generally speaking, yeah, keeping stuff on the edge simplifies some things, but it's not a cookie cutter thing.
Steve, from your viewpoint, working with customers, how much do they worry about security of these systems?
That's a really interesting one, Nigel, because what we find is in POCs, not really. They're after proof of value. So they want to know, can they get it to work? When you then move to the rollout, it is about security. So in that case, they will really care about how does that get done. They have their own standards on site, and typically, as we see, most of these systems in industry, in terms of where we've been working with warehouse and logistics, their IT teams will, ask you to install extra software on the devices to be able to monitor, or to, VPN to clouds if that's the way they're going to introduce their security. And we haven't had any questions about actual device identity in terms of, when it's shipped from factory, has anybody spoofed the device on its way to the end customer? Because we're doing the installs on site, and the builds. So that kind of solves that challenge, which comes up when you're doing more of the in the field ship from supplier.
Okay, thanks, Raj. The next question, we will make all the questions available to all the speakers and provide answers. So any I can't cover now, we'll try and get post the event. A question from Noel about smart cities, which was really about, are we seeing new technologies that are particularly applicable to that domain? But I'd like to broaden it slightly. Is it easier with some of these situations to put in AI systems in a brand new greenfield site where there's nothing there? Or are people having to work harder and harder at adding AI to existing systems? Elizabeth, you expressed an interest in tackling some of the responses to this. And you are on.
No, as the focus of this session was more on the industry side. I think it would really be worth having an own webinar with regard to smart cities and smart communities, and so that would be my feedback. I think we should really, and to answer your question, I think it, from my point of view, it is easier, of course, on the green field, and it will all be about establishing the right connectivity there, and implementing it in existing cities is, from my point of view, much more difficult. But I'm not an expert on that, so I would suggest we would run another webinar maybe early next year and try to really cover a bit more these applications in that webinar.
Thank you very much. And I think I was having a talk to Siemens this morning about why AI at the edge seems to be slightly slower in takeoff in the manufacturing sector compared to some of the other sectors. And one of the points they were making was that there is equipment currently installed in factories which has got quite a long lifetime. And people are not going to just replace equipment to buy the latest one with a bit of AI in there. And that there is a real challenge of how do you add AI into an existing factory environment? Gash, you got any thoughts on that?
Yeah, certainly. I knew the question was coming my way anyway, but it's absolutely about legacy systems, and I think this has been one of the biggest challenges from a manufacturing point of view. Is that, you know, the common sort of perception is that if things are working, leave them alone. You know, don't fix something that's not broken. But added to which this sort of rate of change has come. It's been almost like a separation between the shop floor systems, the office systems, the customers, and so on. But with the advent of Industry 4, with the advent of, you know, all the sort of smart technologies, you know, we've got to get connected. And this has been the challenge, because again, a lot of people are always talking about, well, why do you need to send data to the cloud? It's really analytics you want in the cloud. When you're talking about manufacturing, you simply are working within the constraints and confines of your process. So you really need fast information at that process. So I think that the challenge really is, you know, we've been trying to push cloud computing into manufacturing, but really you need to consider what are the real applications of it. And I think that's part of the, you know, the education, because all of a sudden, and, you know, and I teach people, you know, electricians who, you know, initially we're just pressing, you know, a couple of buttons and you're teaching people a bit of relay logic. All of a sudden, now you're teaching them control systems. They've got to be experts in IT. They've got to be able to upload, download files. They've got to be able to connect, you know, to all sorts of systems. So the onslaught of knowledge, certainly to the manufacturing field, is too fast. And of course, you know, that's why we're talking about, you know, this difference between evolution and revolution. It's absolutely, you know, this revolution that's come, and it's caught an awful lot of companies out. So it's about education. It's about getting people to understand these things. It's about adoption, but a lot of the new systems will come with the new builds. So that I think is the real challenge, is bringing legacy systems. And, you know, not to plug Industry Web, but I'm going to, but quite often a lot of these things, it's all about overlaying systems on existing legacy systems to give you some of the capabilities. So that's sort of the way forward.
Mark, yeah, thanks. Mark, did any of this come out in the survey with the engineers about legacy systems as opposed to working on new things?
No, we didn't really touch upon that, actually. We were really talking about in a slightly more abstract form about, and I think when most people answered that survey, they were probably focused on what they were doing next, new things, as opposed to adding, you know, capabilities to legacy systems. We do get involved quite a bit though I mean, we're quite heavily involved in voice interfaces, and adding voice interfaces to legacy systems is one of the things that we focus a little bit on, because you can do it. It is possible. You can plug a directional microphone in through USB into a legacy system and voice enable it. So it's definitely something that is part of our consideration as a business is how we can retrofit some of these capabilities to things that already exist.
Right, I'm going to ask one final question. So I try and keep to the time. We think 2 hours is probably the right thing. I'm never sure whether we should have 2.5-hour webinars, but and it's from Peter. And really, it's an interesting question. I'm going to try and see if I can get through all of you. We talk about AI systems and we get really excited about the intelligence we're trying to build in machines, but aren't they really based on neural networks and technology that's years and years old? When are we going to get really intelligent systems that have much more ability to adapt to changes? So when's superintelligence going to come and hit the market? Mark.
Thanks. Crikey! I mean, what is superintelligence? I mean, I think we're probably on a path of evolution so far as performance and memory density is concerned, which will ultimately constrain how complex the models are that we can house in economical platforms. So I think I noticed there was a question about quantum computing, which I was hoping you weren't going to ask. But you know, I think that those sorts of things offer the opportunity to do a step change. But for now, at least, I think we're on an incremental change based on density of compute and memory.
Nicholas, are you seeing people getting more intelligent systems than the ones we're currently developing?
That broke up on transmission. People putting more?
Do you think, does the market recognize that the technologies for AI is quite old? What we're doing is processing traditional technology faster and better at the moment with increase in performance in chips. What are the breakthroughs? Can you see a breakthrough coming where it would really change the way things were doing?
I'd say one of the breakthroughs, which is still sort of echoing, is this democratization of tools. I mean, the ideas, a lot of these ideas are pretty old. I remember a colleague back at the Institute going like, well, we call this deep learning now. I used to call that multi-layer perceptron. And I think this sort of, that we have the tools which are available to research labs easily, that you don't need to book time on a mainframe anymore. That's a big change. And I'd say what's now sort of making the big change is that these tools are being translated to embedded systems. So that we're going away from the data center, that we find ways to reduce these complex models into something which is easily executed on simple systems. Of course, we have this ongoing set of discussions about new architectures and spiking networks, neuromorphic accelerators. So there are some very exciting ideas out there. But even today, we already see that people can just sort of pick up a hobbyist board and watch a couple of YouTube videos. And even if it's not mathematically groundbreaking, they sort of get their ideas out of their head into reality. And there's a sort of very rapid iteration happening right now. And it's interesting to watch what people come up with. And sometimes that's not what academia or what product marketing expects at all, but it's going to be something which changes things. And I think this is an exciting process to be in right now.
Gash, are you seeing excitement within manufacturing for AI?
Yeah, no, I mean, and absolutely. And I think it's not a case that there's been a delay. The requirement has always been there. But I think it's how you translate this sort of almost, you know, clunky research, and I call it clunky research, into something that's going to be quite a solid, repeatable system. You know, manufacturers, they can't afford for things just to break down. It's got to be slick. It's got to have a proven record. So, you know, you're always going to find manufacturers almost behind, you know, quite drastically the development curve, purely because they need reliability, they need repeatability. But when you start to talk about some of these, you know, vision systems and the stuff that we're doing now with this intelligent AI, you want to see robots that can see production, not vision systems, but they actually know what to do when things go wrong. So yes, we talk about cobots. Yes, we talk about, you know, humans and automation and systems working together. But ultimately, me as a businessman, I want to press a button. I want things coming out. I want lots of money. And I don't really want any humans involved. That's not the right answer, but that's really the ultimate aim. So how do we still keep humans in the loop? How do we add value to people? And that's really, again, you know, when we sort of start to look at the next revolution, it's the fight back of humans. It's like, well, we've given everything over to the machines, they do it. But, you know, we need to think about the purposes and how we can bring almost like the human elements back into manufacturing.
Steve or Nilam, have you got any final comments?
Yeah, if you don't mind. So I think on one thing, it's about data. It's about the actual the amount of training data that's available. So you know, to make things smarter and to be able to predict better, it's all about acquiring data. It's interesting working with, you know, simulation data. So can you simulate data to create those data sets to allow us to get smarter and see end results? So I think that's a way that's a thing that needs to happen first before we will have super smart. And also acceptance of whatever that super smart is it right? So you need to be able to validate and say why that decision is right. So proving the model is making the right decision. So knowing about how it makes those decisions is also important for, I think, super smart systems in the future to make sure we have the trust in them.
Okay, I'm afraid I am going to end it here because we are 5 minutes over the time slot, but I would like to thank all the panelists and speakers for what has been a really fascinating presentation. For the people, the delegates, if you found this useful, talk to your friends, communicate with your colleagues. We'll make the material available on the net through EPoSS and through KTN. So they'll be able to find out what happened and what they've missed. And we're sorry that some of them missed it. I'd also like to thank Natasha, Nilam, and Elizabeth in particular for helping me put these together. Natasha is the person who works behind the scenes, making sure everything works and does the all the registrations, etc. But it's the backroom people that you don't normally see on a webinar that can sometimes go as the unsung heroes. So I would like to express my thanks to all those people who helped me come on. So I look forward in a month's time. We'll look at mobility. Probably have a different set of presenters. If I get desperate, we may have the same presenters. It will depend. But I would like to thank everyone for joining today, and I'd now like to close. So thank you.